An object starts from rest with a potential energy of 600 joules and free falls towards the ground. After it falls to a height of 1/4 its original height, its kinetic energy is. So here we have conservation of mechanical energy because there's a change in potential energy as it falls and a change of kinetic energy as it falls as well. So we know the initial mechanical energy equals the final mechanical energy. The initial mechanical energy is made up of the initial kinetic plus the initial potential. That equals the final mechanical, which is our final kinetic energy, plus our final potential energy. In the problem, we see that the object starts from rest. So if it starts from rest, our initial kinetic energy is 0, and our initial potential energy is the mass of the object times the acceleration of gravity times height, and we know that equals 600 joules. Our final kinetic energy is what we're trying to calculate and figure out. And then our final potential energy, because it's 1/4 the initial potential energy, because we're 1/4 the height, is 1/4 times 600. Simplifying that, on the left-hand side, our initial energy is 600 joules. That equals the final kinetic energy plus 1/4 times 600 is 150 joules. To get kinetic energy final all by itself, we need to move the 150 over to the other side. Since we're adding that, we'll do the opposite and we subtract 150 from both sides. And so our final kinetic energy is equal to 450 joules, letter B.